Welcome to my projectbazaar.com.
Now we discuss about the product for Memristor-Based non-volatile random access memory hybrid architecture for low power compact memory design. Next we see the abstract for the product. SRAM is a form of semiconductor memory widely used in electronics and microprocessor and general computing applications. This form of semiconductor memory gained its name from the fact that data is held in a static function and does not need be dynamically updated as in the case of DRAM memory, while the data in the SRAM memory does not need refreshed dynamically. It's still volatile, meaning that when the power is removed from the memory device, the data is not held and will disappear. The operation of the SRAM memory cell is relatively straightforward. When the cell is selected, the value of to be returned is stored in the cross-coupled flip-flops. The cells are arranged in a matrix with each cell individually addressable. Most SRAM memories select an entire row of cells at a time and read out of content at all the cells in the row along the column line. Access the SRAM memory cell is enabled by the word line. The control to access control transistor which control whether the cell should be connected in the bit lines. These two lines are used to transfer the data both read and writing process and write operation. The most commonly used SRAM type of in the 60 SRAM, which offers better electronic performance from the all aspects: speed, noise and immunity standby current. The smallest 60 SRAM cell has been fabricated till today as an area of 0.08 micrometer square and was fabricated in 20 nanometer technology based on our proposed designs. In this paper, a new approach towards the design of Memristor-based non-volatile static random memory access cell using the combination of Memristor and metal oxide semiconductor devices proposed. Memristor and MOSFETs of the Taiwan Semiconductor Manufacturing based on 180 nanometer technology are used in the form of single cell. The predicted area of these cells is significantly less and the average of read-write operation power less than 25 times of less than the conventional 60 SRAM based designs in our overall memory architecture. The non-volatile characteristics of cell makes it attractive for non-volatile random access memory architecture designs. Next we see the flow diagram for the product. Our overall process for Memristor-based SRAM design for 4x4 memory architecture designs. First we initialize the SRAM single bit SRAM memory cell designs. This memory cell used to store the single bit storage devices for 60 based transistor architecture designs. The inverting connections to store the results for bit and non-inverse bit architecture results and to apply the transistor wise conditions. The 60 based SRAM design conditions mainly used to our SRAM single cell architecture designs and to develop the 4x4 memory architecture designs for based on the 60 SRAM architecture designs and to combine with 4x4 SRAM architecture designs and to designs for the low power dissipation architecture results. Then to calculate the final architecture results. Then the overall process for the SRAM based architecture designs. This is the storage for read and writing operations for the overall calculations. When the writing operation to be set and to calculate the read operation to be based on our memory cell processing results. Then the data to apply for the SRAM cell designs and to inverting the data for 60 based architecture. Then to processed with read and writing conditions and to final output for the 4x4 memory designs operations. This is the overall process and to calculate the low power dissipation operation. The low power dissipations mainly considered for the dissipate the power allocation for 4x4 memory designs and to consider the leakage power and the overall power consumption for our overall process. Then the leakage power to writing the reduce the noise level for due to the read and writing operation for the memory cell designs. And finally we see the output for the product. This is our final design for 4x4 SRAM based memory designs. These SRAM designs consider the 60 transistor based overall SRAM architecture. This SRAM architecture to implement the our final architecture design for 4x4 SRAM cells. These cells are considered the storage of each bit storage for our the read and writing process architecture designs. These read and writing architecture designs mainly used to store the SRAM resulting functions and to get the final output for storage and read and writing the operation for SRAM designs results. These SRAM designs rules to maintain the design for transistor wise CMOS design cell for architecture level. These are the final results for our overall functions for SRAM designs. Then to run the our SRAM design cells, that's the SRAM design cell to make the 4x4 mesh combination result for architecture results, and to apply the read and writing function for overall architecture design. This is our the data input signal for overall functions, and to the write line activation for processing result. This is our the activation process. This is the deactivation process for writing signals. Then the deactivation process for writing signal, whatever the data input to read the final output results. When the deactivation of writing activation, whatever the data input to apply the process not read the data results to continuous the low position process. These are the final results for our architecture results. When the writing is 1 to what are the data in for 1 0 1 1 0 1 0 and 1 1 function for writing the signal, and to process the deactivation with continuous data losses for reading data input signal, and to activation for when the 1 and 1 0 and 1 1 function to be writing the output final results.